Students, welcome to Max class. Let's discuss basic proportionality theorem or BPT theorem or Thales theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Actually, this is the given statement. DE is the straight line. Okay, so the line is drawn parallel to the side BC. Actually, that is given. Okay, in a triangle ABC, drawn DE is parallel to BC. Actually, what we need to prove here, if a line is drawn parallel to one side of this triangle, okay, the line DE is drawn parallel to the one side of a triangle that BC, then the line is divides remaining two sides in the same ratio. So what are the remaining two sides? AB and AC. So see this, the line DE is divides the line segment AB and AC in the same ratio. For example, the line segment AB is 1 by 2, 1 is to 2 means the side AC also 1 is to 2. Actually that only here we need to prove. Okay, so to prove AD by DB equal to AE by EC, actually that is only given in the statement. So here directly we can't prove this. Then how to prove? Here we need to construct something. So see here, here I join BE, the diagonals. Refer the previous diagram. Next we need to join CD. Then draw DM perpendicular to AE. Next draw NE perpendicular to AD. Why we are constructing like this? Actually, first here we need to find out the areas. Okay, so first we need to find out the triangle ADE, that area. Next to the triangle BDE. Thereafter we need to divide. So already we know that the dividing is under ratio. Okay, so let's discuss how to prove this one. First to take the triangle ADE. Okay, so find area of triangle, that AR, that is area of triangle ADE. So already you know that how to find out that area of triangle. So half into base into height. So half, what is base? Here we can consider as the base as AD. Okay, so base is AD and height. So NE is a perpendicular to AD. So NE is height of the triangle. Okay, so half into AD into EN. Next, we need to find out the triangle BDE. BDE. Okay, so for this triangle here, which is the base is DB and height is NE. Okay, the triangle BDE, if we extend to the left side, NE is the height. Okay, height of this triangle. Next, divide 1 and 2. Okay, so the area of triangle ADE and the area of triangle BDE. Okay, actually here we need to find out the ratios. Okay, these two are equal, we need to prove that. Okay, AD by DB equal to AE by EC. Okay, so first divide the area of triangle ADE and the area of triangle BDE. If we divide these two triangles, see here, half into AD into EN divided by half into DB into EN. So half of will be cancelled, EN will be cancelled. So remaining will be get AD divided by DB. Similarly, next, here we found the ratio of left side AD by DB. See here, AD divided by DB. Okay, actually why we are finding their areas? Actually here we need to prove the line is drawn parallel to one side, then the line is dividing other two sides in the same ratio. For that purpose only, here we are taking the same area. Okay, so here we found AD divided by DB. Next, here also we are going to say take that same portions only. Okay, to find the right side, so take the same area. See this, your triangle ADE. So half into base into height, you know that half into AE is the base AE, and the height is DM. This is the height. Okay, the same triangle, but here we took the DM is altitude. And next, area of triangle DC, this triangle. Okay, so here half into base into height, base is EC, and the height is here also DM. Okay, if we extend the triangle, you'll be get that height as DM. Then divide 3 and 4. If we divide, you will be get AE divided by EC, because here DM will be cancelled because that is a common height. So see here, first here we got the ratio is AD and DB. The next ratio is AE and EC. Actually, we need to prove that the ratios are equal. Okay. The triangle DBE and triangle DCE are on the same base. So already we know that. See here, the triangle DBE and the triangle DC are same base DE. At the same time, the triangle BDE and the triangle DCE in between two parallel lines DE and BC. Okay, see here, the triangle has same base. At the same time, the triangle in between that two parallel lines DE and BC. Okay, so this kind of triangles has same area. So the triangle DBE, the area of triangle DBE equal to area of a triangle DCE. Okay, so these two areas are equal. If these two areas are equal means we can say that AD by DB equal to AE by EC. So see here, the triangle AD, triangle AD is same. We know that. At the same time, area of triangle BDE and area of triangle DC also same. So that means the area of these two triangles are in the same ratio. That means their sides also in the same ratio. Okay. So see this, the areas are same. At the same time, the ratio of their sides are same. AD by DB equal to AE by AC. Actually, this only here we need to prove. Hence prove. Okay, students, if a line is drawn parallel to one side, then the line is dividing other two sides in the same ratio. First, students, let's discuss corollary of basic proportionality theorem. So what is meant by corollary? So that is the subdivisions of theorem. This is subdivision of basic proportionality theorem. Okay. So actually already we proved AD by DB equal to AE by EC. AD by DB equal to AE by EC. So here just to take reciprocal. So DB by AD equal to EC by AE. Then add 1 on both sides. Okay. So if you add 1 on both sides, plus 1, and the right hand side also plus 1. The same time the plus 1, if you transpose to left hand side, minus 1 plus 1 will be cancelled. You will be get the same ratio. If you added 1, we need to take LCM. So the LCM is AD. So 1 into AD, AD. Similarly, right side. So the LCM is AE. So EC plus AE. So DB plus AD. See this DB plus AD, we can write AB by AD equal to EC plus AE. EC plus AE equal to AC. So AC by AE, or we can take reciprocal AD by AB equal to AE by AC. So these two conditions are these two corollary also possible if a line is drawn parallel to one side of a triangle, then the line is dividing remaining two sides in the same ratio. Okay, so that time these two conditions also possible. So AB by AD, see this AB divided by AD equal to AC divided by AE. Okay, that time also the ratios will be same. So we can take AD by AB equal to AE by AC, or AB by AD equal to AE by AC. Okay, so this corollary also possible when a line is drawn parallel to one side of a triangle. Students, I hope you all understood this concept. Thank you.